Okay, we're going to get started. Thanks everyone for coming. My name is Dennis Sylvester. I'm the interim chair of ECE, and I'm delighted to welcome our speaker today, our talk by Mo Faisal, who is receiving this award here. I'll show it to you. It's a very nice award. I'm sure he'll display it very prominently. This award is called the ECE Rising Star Award, and it's really aimed at younger alumni who are doing great things, achieving early success in their careers, and engineers to watch, and so on and so forth. So we have identified Mo as the winner this year. His role is founder, president, and CEO of Movellus. He'll tell you a lot about Movellus. That's what he's going to talk about today, and what it is, and how the path that took him from a student here to this CEO role. He received his bachelor's degree in Waterloo, the University of Waterloo, and then his master's and PhD degrees here in ECE. He's published a bunch of papers. He holds 12 patents, which is probably even more important for his current role, the patents than the papers. But he was named a top 20 entrepreneur by the Zell-Lurie Institute. So if you're interested in entrepreneurship here at Michigan, that's one of the big ones over in the business school, and they do a lot of work on entrepreneurships. He competed in a bunch of business competitions. I don't know if you're going to talk about that here as part of the process of building a company out of academia, but really important way of starting out. And Movellus was really an idea more than a company that time, and he went into these competitions and won a bunch of money and started things out. The company I just mentioned in passing was co-founded by another alumni from the department, Jeff Frinberg, who was CTO until just recently. But so we had a run in the mid 2010s where we had a bunch of startups coming out of the chip design area, and Movellus was one of the ones that we're really proud of to have come out of ECE. So I'll stop now and let Mo have the floor. So, yeah.
Thank you, Dennis. I think the talk is done, right? With the round of applause. So it's been quite an interesting day. Walking in this morning, I was reflecting on, hey, how am I feeling? How's my nervous system walking into these buildings where I used to be a student? And I think I've mentioned it to a couple of you today. I have this weird feeling, the same feeling that comes over you when you walk into a room with your parents. It doesn't matter how old you are, you still sort of revert back to that, teenage years, because they try to tell you what to do and you resist. Similar thing happened. It's despite whatever I'm doing or what I've done and I've graduated, I feel like a student. Wait, I never had access to this room, right? I didn't know this is what it looked like from the inside. So it's been quite powerful and beautiful day. So I want to thank Dennis and Sylvia for arranging all this. It's been a really beautiful day. So today I'm just gonna tell you about my journey. I don't have anything profound to say. I'm just gonna share what I've done over the last, at this point, almost 10 years, actually 9 years. And hopefully some of it is insightful. Hopefully some of it actually gives you an idea how painful this journey is, and maybe there's some funny moments as well. So I'm sure you've heard of it. It's the lazy students that make it, right? It's the students that sleep. So this is actually me sleeping in the office upstairs, in our Mickle office, and it's a lot bigger now. I think it's 3 times the size now. It used to be a lot smaller. And that's my friend Nathan Roberts in the background, who's now an investor. Okay, so this is just an insight into where it all began. It began from taking naps upstairs. I'm partially kidding because this was actually during a tape out, so it was not taking naps. It was surviving on 2 hours a night sleep kind of thing. So that's why the nap was being taken at the desk. So before I get into the story of the business, I want to reflect a little bit on the nerdy stuff. We're in the engineering building, electrical engineering, and I have to give a little bit of the taste. One of the reasons I feel like I stuck with the CEO track is because I was a bad engineer. So don't ask me too many deep technical questions and don't ask me to explain my thesis. I don't remember anymore. But, this is what it was. The problem statement that was given to me, it was actually the second problem statement. I came to Michigan because I was interested in microwave circuits. I wanted to do research in microwave and RF, and that was the area that Dave, at least RF side, Dave was covering. But we tried to do, near field capacitive communication for about 6 months and realized that doesn't work. The capacitors have to be too big and it's not going to work with integrated circuits. So then I got redirected to this project, synthesizing analog. I had a little bit of resistance. I want to be an RF designer. What? I don't want to do this. But for whatever reason, I just decided, let's just stay open. Let's see what happens. So the problem statement that was given was synthesizing analog circuits. What can you do? What can you do from a methodology perspective? What can you do from the architecture perspective? And I was not the first one to work on this. There was another student before me, Young Min Park, who is at Apple now, I believe. He started this, and this problem statement was handed to me. All right. When I first looked at it, I said, okay, sure, we can create analog functions, but the performance doesn't get even close to custom designed circuits. Then what's the point of creating things that don't perform? What's the point of inventing a new car with the mileage is like 1 mile per gallon? No one's going to use it, right? So I asked myself, okay, what are some of the things we can do? Right. First thing I actually somehow intuitively said, hey, I'm just going to question the problem statement that's being given to me. Synthesized analog was the problem statement. And I said, what does synthesizable mean, really? So let's just look at, sort of the analog circuit design flow. This is a cartoon, by the way. People in the industry will laugh at this cartoon because there's about 10 other steps after this. But, I did this when I was a student, so you can forgive me. So basically, in an analog circuit, you start, you say, hey, I'm going to design an op-amp. You start with a topology, then you do, device sizing, you do some simulations, and then you do physical design, you extract, you integrate, and you just run iterations over and over and over. And most of these iterations, actually all these iterations are custom. You have to manually go change the device size and blah, 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 manually change the layout, and then just keep going. This is what makes analog design, tougher and even, not as efficient. But we had a lot of purists actually in the industry talk about unless you can push a button, it's not synthesizable. And when I actually looked at what is synthesizable, and if you look at the digital circuits, right, first thing is you inherit a standard cell library, right? You actually don't realize how much of a custom design work goes into the standard cell library, creating that alone. Yes, after that you can push a button, right? So I said, okay, wait, I'm gonna just do that. We'll just take this, we'll pay a lot of attention to creating a cell and optimizing it custom, and then after that, push button. So automatically generate the physical design, automatically validate, integrate all those things, right? Now, I think now it's known as cell-based design. I believe a couple of people use that term today. But in my opinion, it's the synthesizable, right? But yeah, so you can, put this right next to standard digital design. Hey, somebody's doing a lot of custom design in standard cells anyway, so what's the difference, right? Is it because I am doing the standard cell as opposed to some mysterious company out there? So anyway, this is one of the key contributions. Before that, we were all sort of push button just based on the standard cell library, and there were some limitations there. So this is one of the things I did on the methodology side. Hey, let's just get out of our head. Let's do some a little bit of custom work in there. The other part of making synthesizable analog closer to custom analog was some performance issues, right? So this might be a little bit too nerdy. I'm not sure how many circuit designers are in the crowd. Maybe we can get a show of hands, who understands this diagram? Okay, at least one person. Okay, good. All right, a few. So basically, this is showing the performance of oscillators, for example, or PLLs, was limited by the smallest buffer size or inverter size that you can put down, that you can control, all right? And if the smallest is too coarse, if the smallest step size is too coarse, you're stuck. You're like, hey, how do I improve the performance of this? So this thing shows if you actually enable that, that second buffer through that enable control signal, you basically get the entire, delay step change, all right? And that, step, I think it's 10 picoseconds at a gigahertz, that causes, many megahertz of change in frequency. So that's too coarse. The quantization noise of the oscillators was too high. So we got to figure out how to improve the quantization noise. Otherwise, synthesizable analog is never going to get close to, to custom analog, which is what the goal is. So I asked myself, okay, I can't modify the space domain. So we live our life in time and space, right? Those two axes. So I'm, the standard set libraries and limitations of technology, I'm done with my space resolution. I can't go any smaller. What about time resolution? Like, what if I turned that buffer on only for a portion of the period, not the whole time, right? And this one, the result of this was actually huge. It was like 20x improvement in the step size, 20x reduction in the quantization noise. And that's one of the things that actually broke the barrier of, hey, custom analog, synthesizable analog can be on par with custom analog, all right? So the result of that is basically this. Like, if you put it all together in a ring oscillator, and again, this is, I promise this is the last deeply nerdy thing I'll say, and then we'll get to the fun stories. So you put it into a ring oscillator. This is how you basically generate it. PWM is a pulse width modulator, which is a circuit you can build with the same delay cells, and then you can control it. And this resulted in 20x reduction in the quantization noise, and that was one of the early patents. One of the I think this was my first paper that was published at RFIC. So this is one of the key innovations that resulted. There's a few more, but I didn't want to take the whole time just for talking about that. So as I put down like those slides, I just said, wait, this sounds like a really smart story. Like, who thought of this, right? And I was like, wait, this sounds smart because I'm looking back. At that time, from day to day, it was frustrating. I had no idea what the heck I was doing, right? So, but looking back, I think it's still important to actually reflect. However, I was actually asking myself the right questions, which is even more important than having the right answers. So this is true across, I think, in any area of life, but really in particular in PhD, because I started questioning the terminology. And then I started like questioning what the purists are saying. That's when the insight, like, hey, it can be same, synthesizable as synthesizable, right? And that's what led me to like adding a custom cell, all right? And then the second part, basically, I've already, given you insight on this, is like, if I'm stuck in space domain, maybe I can do something in the time domain, right? So right questions. If anything I share, this is something. It's a skill that I'm constantly trying to develop every single day. There's all kinds of techniques you can utilize, but asking the right questions is what got me through the PhD in 4 years, 8 months, and out of those 10 months I spent actually away from campus. So technically like 3 years and some, which apparently is really fast. So. Okay, so any questions about the nerdy stuff before I tell you about the company? Okay, I'll have time at the end as well. So there were a lot of factors, things happening in the air. Like people ask, like, oh, when did you have the idea? Like, did you always know that you were going to start this? And the answer is no, absolutely not, right? So like, I didn't just sit there and visualize this crazy vision of myself in the future starting this company. So I want to touch on a few factors that were around, around the university, around Ann Arbor, that actually helped solidify this. And it really is, beyond that, is just being open. Like, having the intention, hey, I want to start something, and then like looking at what's going on and responding to some of the opportunities. And that's how we actually arrived at this. First, one of the factors was industry's curiosity about my research. Since then, a lot more companies are interested, but at that time, when I was a student here, Intel, STMicro, Freescale, were interested. They were curious. Like, we would submit papers for publication, and these reviewers from the industry, they would send us emails like, hey, we're curious about this synthesizable thing that you're doing. Can we talk more, right? And Dave Wentzloff and I, like you sat down, I was like, this is interesting. It's an interesting trend. Let's make a note of that. So this is a really important factor because a lot of the research can be too far out there, so not immediate applications. But this was an indication that actually said, hey, we can do something here. The second part, and an important factor, was actually, a friend of mine, the guy in the background. This is 2012 sometime, I don't know the exact date. He said this exact, sentence to me, which this is how I remember. I don't know, in reality, maybe something else. It's like, oh, you should start an IP company selling PLLs and call it Movell. All right, this is Nate. So Nathan, so he said that. And, usually I would just like, brush it off as a joke, whatever, you forget about it and you have a tape out to worry about. But it really lodged into my subconscious because it happened during a late night tape out hallucination. All right, so it got stuck and I couldn't let it go. and this was 2.5 years before starting the company. This was a really important factor, right? And on top of that, there was something in the air, and I see actually I'm really pleasant to see that this is still in the air here, right? So a lot of things around Ann Arbor, right? So a couple of things that I'll mention, and my desire here is to actually just like raise some awareness. Like I didn't have a vision board and went for it. It's like, oh, I just paid attention to what was going on, and maybe I can bring some things together. A lot of resources. So Tech Transfer Office, CFE, Center for Entrepreneurship. We already mentioned Zell Lurie Business School, and obviously the ECE department. There were resources. There were help available everywhere. And I was able to actually get quite a bit of grants actually out of just working with CFE and OTT, right? So Juhi is here from OTT. He's been greatly helpful. There's a lot of resources and just wisdom and mentors available through OTT and through our network. So even before I started the company, I was able to connect with former students, alumni, current alumni, former students who had started companies, right? And they gave me a lot of wisdom, a lot of guidance, hopefully, and I hope to give some of that, back. But that played a huge role in, further, having the confidence like, hey, I can do this thing because this is, it's basically doing something with my life. This is my life's mission, right? The other really important factor was I was able to do some business competitions before graduating, okay, and somehow ended up with $47,000 in the bank, not my personal bank, the company's bank. And I was like, wait, I'm not gonna be homeless if I do this immediately after graduation. So this is a big factor. Believe it or not, this was a big factor, right? And on top of that, another factor was when you're a grad student, you're used to living off of whatever, $1,800 stipend, I don't know what it is now. That's a lot of money. That's 2 years of runway, right? So I was like, all right, I have enough time to go try something and experiment something, and then see where it goes. And all of these factors, came together to finally giving me the confidence. And all these things happened before graduation, by the way. So that you can only do it here. There's faculty that'll support you. There's faculty with the vision. There's Tech Transfer Office, CFE, you name it. There's alumni that'll support you. All of these things happen before graduation, right? One of the things I actually want to I really appreciate is Dave Wentzloff's openness, because when I was doing this, you can imagine how much energy I was putting onto my research, right? So for the last 8 or so months of my PhD, it was all focused on this. And it still had the right motivation. We're translating that research out into the commercial world, but that really helped a lot. So, started the company, and what do I do now? What are you supposed to do? How do you figure out if you've never done, right? One thing that was really helpful was some of the grants that I've already mentioned. Their milestone was to go talk to industry experts and potential customers. And I remember actually I had spoken to, I think by the fall of 2015, I had spoken to 60 different people in the industry to meet the milestones of those grants, okay? And that was hugely helpful in training me actually to how to have a conversation about, sort of a supposed product and vision in the future, right? That played a huge role, right? But I'm gonna touch on a few key points, key turning points, okay? First key turning point, this is actually a picture from 2015. This was in the Haddad room. This is Shaheen Hidayat. He graduated from UM in, I believe, 1982. Successful entrepreneur, has been there, done that, many successful companies. He holds a record for the fastest IPO, 3 years from seed to $700 million IPO in the 90s. He holds that as a founder. I met him in this room. I think I may have been a couple people down this. I couldn't find the picture of the wider lens. But I met him and we hit it off. I told him hey, I have this company, we've got some grants, and I'm talking to some people. I don't know what I'm doing. Would you like to help me? Give me some insights. And I think just being open really actually that resonated with him, and he took a liking to me, and we started talking once a week. And for about 6 months, he coached me, and 6 months later, he ended up putting money in investing. He actually started a fund to invest in us. Before that, he didn't have a fund. He's Like he had just sold a company for $400 million. His second company, he was just hanging out, like doing things. But he actually started a fund to invest in us. So really built a very strong relationship. Like here it is, alumni relationships, paying off, paying attention to the things that are going on around here. Another sort of turning point was, this is actually 17th of November 2015. This is the day we got funded. So these are Ann Arbor Angels. They came to our office, which was in downtown. It was a basement under a garage. So we used to say that, hey, we have double luck. So it's not only a basement, but also a garage. And it used to have garage doors in the basement. So it was fun times. But anyway, this is the day they signed and our first dollars in. And it was really important day. Like, oh my goodness, I can convince people to give money. That's crazy. So, right. So after you have money, okay, I got money, I got some story. Who's gonna do the work? Right? I can't do it. Like, doesn't matter how smart I think I am. I have a PhD and blah blah blah. I can't do the work. So I got to recruit the team. How do I recruit the team? By the way, I mentioned like looking back, you connect the dots. This is an example of the same thing. I didn't know this at the time. This is only like, wait, I had to have all of these factors in play in order to recruit people. And some of these things maybe I was doing intuitively. Some of these things, maybe I was learning. Some of these things my advisors and board members were doing for me. First is vision. So like if you want to convince somebody to go on this mission with you of starting a company where you have no idea where it's going to go, you got to have a vision. Like it doesn't have to be correct, right? You can change it from day to day. Like really, actually, early days, you may have to change it from day to day. Later on, you don't want to change it day to day. So first thing is vision, all right? Second thing is culture. So what's it going to be like to work together, right? Or am I going to be yelling at them every day, right? Or is it going to be more friendly? Is it going to be genuine feedback? Or is it going to be, sort of like old school 20th century style, like hard driving boss? All these things are important. So you gotta like understand, hey, what's it like to like work with me, work with the founders, and you gotta have some clarity in order to actually give people an insight into what's it like to work together. Meaning, so are we doing something that's important? So it can come in multiple ways. In our case, because a lot of people are doing research in circuits, so the meaning part is already taken care of. Like if they're doing the circuits, they're interested in it for some reason. So then we gotta sell them on a big enough vision. So giving meaning to work is really important. So we gotta have insight into, hey, how does this connect to the greater forces in the world? Like, okay, synthesizing analog, so what? Synthesizing analog, maybe we can help some IoT product to come to the market in the power envelope that it can come to the market, and then that can open up, for example, give access to people who can't read any language to then start using smartphones, right? Like these kind of things, you gotta have, some of that and give meaning to the team. And of course, economics, no one's gonna work for free. So you gotta make sure it makes sense for economics. And this is where you have to, project out and, hey, how big the company can be and what can be the returns and whatnot. So you gotta figure all of it out to recruit the team. The flip side of that is actually, how do you attract funding? Because $500,000, which is what we got on the 17th of November, the picture that I showed, it's not enough. So how do we get more money? Because that's what's needed to build the next wave of products. So it still starts with a vision. That's a constant. Because if it's kind of like recruiting a team, except that it's the external team, right? And then the VCs also look at the team. Like, is the team committed? Is it a bunch of part-time people, like they have their full-time job, and then in the evenings they're doing a couple hours? They run away from that, right? So they want to know that the team is actually committed. They're committing their careers to this. All right, could be for a couple of years. It doesn't have to be forever, but it needs. They got to see the commitment. Of course, they got to see the product, right? It's no longer technology. So the early angels, so early angels are okay with technology and they're okay helping you, turn that technology into product. But VCs want to see a vision for product. And the last thing is market, right? The same way, economics got to make sense for the team, for investors, big enough markets, so that they can actually they can actually see the all right, okay, my team members are here. So market's got to be big enough because that's how they get the return. So like if you're going to sell iPhones to 500 million people, that's a big market, and investors like investing in those kind of things, right? So these are some of the ingredients. In reality, it's about 1,000 different factors. This is just a few buckets. So please take this as a grain of salt. This is not exact science, right? So the second turning point. So this guy next to me here, he's the founder of Analog Devices, Race Data, all right? So as we're chugging along, making progress, getting all those ingredients in place, the team and the product and the market and everything, I was connected to Race Data. His first boss was Bob Noyce, the founder of Intel, all right? So that's the generation he's from. So, and he's still on the board of Analog Devices. Somehow he took a liking to me and Jeff, and he really wanted to actually partner with us and help fund the company. And this is his picture in Ann Arbor, downtown Ann Arbor, in our office, right? So this is huge vote of confidence. And how did I do that? I don't know, just navigating, working with Shaheen, working with the university, working with, by this time Intel Capital had already invested in us, working with them, and then slowly, making the case to Ray, hey, I think we're doing something big. And and since then he's put in millions and millions of dollars in us. So it's really important factor. So, okay, so where are we now? Where's the company now? So we are designed into smartphones, okay? Not like iPhone or Google or anything yet, that comes later. But I want to actually share that story. So in the world, there's about 1 billion people who have the economic resources to buy phones, yet they can't read, okay? So how do they interact with the phone? So one of our customers, did a really low power chip, and we provided the clocking infrastructure to them. Really low power chip, which is less than 10 microwatts, which recognizes words. So you speak into it, it recognizes commands, all right? So what they've done is actually they've opened up this whole market. Now people who cannot read can actually interact with smartphones. Okay, and if you think about, on one hand, smartphones are, annoying and they keep us busy and distracted. But the other hand, it's also access to healthcare, access to education, and it's opening up huge opportunities. Yes, we didn't do the chip, however, we played a role. Without our clocking solution, no way they would have been able to hit that envelope, right? We have customers in AI, we have customers in data center, we have customers in aerospace, so a lot of stuff going into space these days, IoT and automotive. So my marketing team likes to say, soon in the future, if you're driving a car, you'll be driving a car with Movellus technology. If you're using a smartphone, you'll be using a smartphone with Movellus technology. You go look at your smart Ring things in your home, it'll have Movellus technology in there. You connect to Wi-Fi, it'll go through Movellus technology. Right? You do video calls and you run simulations at the data center, you'll be using Movellus technology. So it really is fundamental innovation. It does require focus. However, over time, it will be everywhere. And you can already see in the markets. So we're designed into 25 different chips, 100% first-time silicon success, and it's really, really exciting times ahead. So I find this actually quite rewarding from, starting a little bit of a research project and then stumbling through and before you know it, we are designed into all these things, right? So it's really, really exciting. So I want to shift gears a little bit. So that's the company and where we're at. Another big transformation that has happened is actually me as a person. Getting out as a PhD nerd, right? Hey, I did this research. I'm the top expert at this area, and then actually being forced to develop into a leader, right? So I'm gonna only focus on a few important items. This is a really, really important factor in my opinion, okay? First thing is, all right, so imagine having a PhD, the company's started on your research, you have the patents in this. However, as the leader, you have to somehow figure out a way to be the dumbest person in the room, okay? If you are not that means all the decisions and everything that happens in that room is limited by my abilities, all right? And guess what my abilities are? My abilities are that of a technologist, not a business person, all right? So this is a difficult transition. You have to go through a lot of introspective, hey, I have the technical side, but these other areas I need to defer to my team, and it requires big shocks to the ego. And I can tell you, I love my all my friends that have PhDs. However, there's a lot of strong ego that needs to be worked with. So the other thing is one thing I notice is actually my emotional surface area that I talk about, right? As an individual, an individual contributor, my emotional surface area is just, hey, I got to get my project done and on time, and got to make sure my boss is happy, and that's probably the end of it, right? But as you start leading a team, I just realized that like actually my emotional surface area is a lot bigger. So if one of my engineers' nanny is sick, in a certain week, that affects a project, that affects a customer. Well, guess what? All of those roads lead to me. So it's no longer just, okay, if I can keep my own personal life in order and everything, emotionally, like I'm okay. No, it's actually every single thing that happens to my entire team, things that happen to the customer, things that happen to the markets, things that happen on a geopolitical scale, all of those things, start affecting. So learning to metabolize emotions. It's like really quickly, like, I'll have a reaction. It's like if China-US relationships affect, one of my customers, I'll have a reaction, but I gotta, like learn to fail gracefully and then turn around and actually, keep going. And that was many, many, many years. This is not something, you can just turn on. This is, fighting with yourself actually for many years to develop some of these things. And it's still a journey that I'm on. The other thing is, so internally on our teams, we actually do these personalities like tests to figure out communication styles and problem-solving styles, and we do the birds. Okay, so there's the eagle, the parrot, the dove, and the owl. Okay, another challenging thing that I had to learn was respecting different styles of thinking. One thing that we don't realize is actually being in ECE and being like doing research and whatnot, we're always around people who think very similar to us. There's a little bit of variance, but not really. Like 80% of the people think very similar to us, and that's not how the real world works. All right, like if you want to do something with a team, you have to learn to respect different ways of thinking, different ways of communicating, different ways of solving problems. Some people are more intuitive, others are more data-driven. Some people are more relationship-oriented, other people are more stability-oriented. So that's a really big lesson that I had to learn. So let's have a pop quiz for everybody. What do you think are most engineers? What type? I only have 2 guesses. That's good.
Owl.
All right. Yeah. Yeah. So 80% of our engineering team is owls. So there's a few anomalies actually who are like parrots, but yes. So and see, like we're actually laughing. Like, this is an important thing because you depersonalize as well. You don't want to actually make it look like an attack. Oh, look, we're a bird. We're laughing. Okay, cool. Now we can actually respect each other's styles and work together, right? Like, hey, don't be an owl. Like, let's step back and So it depersonalizes that, like, oh, you're not listening to me, kind of thing, So I really think everybody should do it. Actually, when we did it with the team the first time, half the team actually wanted to do this test with their significant others. They were asking, like, hey, can we do it? So anyway, so this is another area of development that I am continuously working on. So the last thing I want to reflect on is I've given you my anecdote, like my stories, but when I actually reflect on this, taking technology and research, turning into a startup with a product, there's a few areas while you're still in school. Okay, that's the thing that I'm actually like focusing on that you can do. All right. So first thing, obviously, you have to answer is, hey, like it's in research setting, you have to get 1 or 2 chips working and you're happy, you can publish and you can graduate. But the real world doesn't work like that. You have to ship 1 billion units and all of them have to work, right? So we have to be honest with ourselves and actually work on that. And the best way I know how to do that, I did not do it the best way, I did it the wrong way, or the long way, is very quickly within the first 5 team members, if you're recruiting, get somebody who's been there, done that. Like one of, maybe a VP of engineering, maybe somebody who's done and shipped chips in billions and billions, or at least millions of units. That is the absolute best way, because some things you cannot, like, experience is the only way to do that. And, shipping billions of chips is actually, experience is the only thing that gets you there. The other thing is actually take advantage of the resources. So if you have some technology, but you want to take it into a startup or create a startup, tech transfer, and then other resources as well. But tech transfer, go talk to them. Go talk to Juhi first, right? And hey, I have this. What can I do? What are the resources? And they'll guide you through. Actually, when I did this, Jack Miner used to be the head of OTT venture side, and he guided. Like, he was really, really, really helpful, and guided me through the process. Hey, this is what you do. This is this, like, you have to apply for option to license. You're going to file a patent, file a disclosure, option to license, and then from there, here's the milestones you have to define, like all those things. They walk you through it. Whether you like those terms or not, like, that's a different question, but at least they walk you through the process, okay? So the other thing is education. So I've alluded to that I'm a beneficiary of all the education, non-technical. Well, I shouldn't use the word technical. Even business people think they're doing technical work, but non-engineering, okay? So CFE, I remember taking a course with Jonathan Fay. I believe he was the director of CFE then. It was the course was all about keeping the founder in the C-suite until Series B. That was the topic of conversation. Like, hey, how do we actually create leaders as opposed to just default assume like, hey, you're a technologist, go get a CEO kind of thing. Like, no, how do we develop people to stay in the C-suite until at least Series B, because that's like growth stage. After that, maybe it's a different kind of problem statement. So really important, like, take advantage of all those resources. And then, like, there's no replacement for like luck, being open to what's happening around me. Like, hey, who should I meet? Who should I hang out with? Oh, maybe I should go to that talk. It seems to be, somebody who's done like, what I'm interested in. So just being open, right? Like, there's no replacement for that. And this is where, your ability to take risk and your risk tolerance becomes really, really important. Okay. So the last thing I want to, talk about here is just reflecting. When I started, I thought like, oh, I'm going to make N million dollars by a certain age. I'm going to sell this company and I'm going to retire early. Like, I swear to God, actually, an investor asked me, and I told him this, like, hey, I want to make this many $1 million by this age, and then I want to retire early. And he laughed. But over time, like, what I've actually realized is, the abundance will come, but in reality, it's about this right here. Like, what can I, what have I learned? What can I share, with others? We have launched careers. Like, we've had many, fresh grads from the University, U of M, come in and work with us. Some of them have moved on and gone to bigger companies that are doing great things. So launching careers, training people, that's something that'll keep on giving, forever. Maybe not directly to the company. It doesn't have to be directly to the company, because we make an impact. Like, we live in a big system, right? And anything we do to contribute, comes back to us in an indirect way, whether we know it or not. So it's really been, about that. Like, one other example that I'll give you is, it's a bit more, personal. So when I was a kid, my parents moved to Canada, from Pakistan, and my dad's an engineer. And he had 20 years of experience like in Pakistan, but when in Canada, they kept asking for like, hey, but do you have Canadian experience? And he didn't. And as a result of that, I remember the first engineering job that he got, he was paid half of what somebody of his experience would have gotten, because they could get away with it. The employers could get away with it. It's somebody with no Canadian experience can get away with that because my dad needed a job. Right? So all these years later, actually, in 2018, I had an option. So a recruiter told me like, hey, this engineer is moving from India to Canada. You don't have to pay her the same amount. You can get away with basically whatever, because just for her, having a job is a huge deal. And that was that was a moment like, oh my goodness, like, look, here it is, like, whoa, like I have to make a choice. And at the same time, I have to make a choice. Like, I'm responsible for the runway and the financials of the business as well. It's very, very easy to say, okay, like, let's just pay her the minimum and get her in. And I that's when I realized, like, oh my goodness, this is what it's about. That moment is what it's about. Can I actually change the options, change the choices that my family was affected by, and pay it forward, and hopefully another family is not affected by the same choices. All right? So that's the last thing I'm going to say, and hopefully you have some questions. Thank you.